The universe. The only place where no one can ever find an end. This is the beginning of an incredibly small part of that infinite space where we live today. It was the origin of everything, including planets, stars, galaxies, the sun, and all the matter and the energy that exists in the universe today. Although there are several scientific theories to go into explaining this, the most popular and widely accepted cosmological explanation is the Big Bang Theory. According to the estimations of this theory, the universe began as an incredibly hot and dense point, roughly around 13.5 billion years ago. So let's roll back to that era. In the humble beginnings of the world, there was nothing but an infinite universe, deeply sunk only in extreme darkness. Everything that exists in the universe today was squeezed into an exceedingly small, infinitely dense point, which was only a few millimeters in circumference. It was like a supercharged black hole. An enormous explosion in it led to this small mass beginning to expand rapidly. Throwing billions of dust particles and debris all over the infinite space. All the matter and energy in the universe today is actually a result of this explosion. At that time, the universe was unimaginably hot and dense. Its expansion eventually led to its cooling down, which also made it less dense. Within a few minutes after the Big Bang, the universe had cooled down enough for quarks to bind together and form protons and neutrons for the first time. Quarks are a type of tiny elementary particle and a fundamental constituent of matter. Atoms are made of protons, neutrons, and electrons. These neutrons and protons further comprise of quarks. After a few moments, the space was full of protons and neutrons. Due to the continuous expansion, at this time, conditions were cool enough for these protons and neutrons to form nuclei. Nuclei are the plural form of nucleus. Nucleus is the small and dense region consisting of protons and neutrons at the center of an atom. Around 380,000 years after the Big Bang, electrons appeared for the first time to attach and continue orbiting around nuclei for the very first time, forming the first atoms in the universe, helium and hydrogen. Around 1 billion years after the Big Bang, all of these hydrogen and helium atoms began to accumulate into regions of higher density and formed a dense, giant gas cloud called a nebula. As time goes on, this giant cloud of gas got flattened into a disc shape by the centrifugal force on it. This gas cloud had been warming for millions of years, as the temperature inside of it rose by millions of degrees. This temperature was hot enough for nuclear fusion. Along with a tremendous energy, nuclear fusion generated. Nuclear fusion is an atomic reaction which provides the power to keep alive every star in the universe, mostly converting hydrogen into helium. This allowed stars to be born all over the universe, slowly ending the darkness of the universe. Due to the high gravity created between these stars, they began to collect again into dense regions and formed the first galaxy. Over time, hundreds of billions of galaxies formed in this way. Some of these galaxies consisted of around 100 million to a couple billion stars. The stars that existed in these galaxies appeared mainly in three colors. The largest, brightest, and hottest stars appeared in blue. These blue stars were about 1 to 200 times the mass of our Sun. Red stars were small, cool, and dim. Yellow stars were around the size of our Sun. Among these billions of galaxies, the galaxy that formed our solar system is called the Milky Way. Our Sun was born around 4.5 billion years ago in a minor spiral arm of the Milky Way galaxy. It originated from a giant, rotating cloud of gas and dust called a solar nebula, which collapsed as a result of its overwhelming gravity. Then, it began to spin and flattened into a disk, just like galaxies did. Most of the material was pulled towards the center, which accounts for an astonishing 99% of the mass of the entire solar system. The pressure in the core was so great that it released a tremendous amount of energy. With this, our Sun was born. Meanwhile, the remaining material was distributed at varying distances, away from the axis of rotation. Then, these clumps of asteroids began to smash and stick together due to the gravity, forming larger objects called planetesimals. Some of them assumed the shape of a sphere and became planets. Other, smaller, leftover pieces became asteroids, comets, meteoroids, and small irregular moons. Eventually, around 8.7 billion years after the Big Bang, the beginning of an incredibly small portion in that infinite space was in place, forming the early stages of the planets that were to be called the solar system someday in the future.